In this video, we're going to be talking about systems and how to define them, and also the three different types of systems. There's open, closed, and also isolated systems. What's the difference between them? So let's start with systems. First of all, what is a system? It's real simple actually. A system is literally just the subject of focus. So whatever you're trying to study is the system. Okay. The surrounding is literally anything else other than the system, other than the subject that you're trying to focus on. So let's take a look at this example on the bottom here with this kid who has a fever. Now, fever means that you have a high body temperature, okay? And this right here is in Celsius, 38 degrees Celsius. And in terms of like Fahrenheit, this is actually 100.4 degrees Fahrenheit, which is really hot, right? Hot enough to boil water if it reached that temperature. So let's consider what would interact with the system based on how we define it. So it says right here, consider the following defined systems. Let's start with the first one, the very first one. What if we said that the system is the ice pack? Okay, that means the ice pack is what we're talking about, right? And on the diagram, I'm gonna highlight the ice pack right here. If the system is the ice pack, then that means the surrounding is literally everything else other than the ice pack, right? I'm just gonna write everything else other than ice pack. Okay, everything else in the universe other than the ice pack. That means, like in the picture, you can say, okay, that means the kid is part of the surrounding, right? And the thermometer is part of the surrounding. The pillow is part of the surrounding. The bed is part of the surrounding. The air is part of the surrounding, right? Everything that's not the ice pack, that's not the system, is considered the surrounding, all right? Now, there's a question right here that's asking, okay, what is transferring in and out of the system? When you're talking about systems and stuff that transfer in and out, we're talking about energy and matter. Is there any energy transferring in and out? And is there any matter transferring in and out of the system? So again, the system is the ice pack. Well, the ice pack is, since it's on a kid and the kid has a fever, like it's a high temperature, right? The ice pack is actually getting energy from the kid, right? It's receiving heat from the kid. And that's because they're different temperatures. So if you have one object, let's say it has a temperature of 80 degrees Celsius, and it's touching another object, and let's say that object is like, 60 degrees Celsius, then the object that is hotter gives energy to the object that's colder until it gets to a point where they are the same temperature. So this is the before picture. An after picture can look something like this. So same objects, except they might arrive at a temperature that's in between, right? Something like that. So heat will transfer from a hot object to a cold object until they're about the same temperature. So in the case that we're talking about, right, with the kid and the ice pack will eventually absorb enough heat until it's about the same temperature as the kid, okay? And you might be thinking, well, could we say the opposite? Is the cold transferring from the ice pack to the kid? You don't want to think about it that way, okay? You always want to think about it in terms of how heat is transferring. The heat is transferring from the kid into the ice pack. That is how you have to think about it. Heat is transferring from the kid to the ice pack. And that means since the kid is losing heat, the kid is feeling cold. Alright? It's the fact that heat is leaving the kid, and that's why the kid is feeling cold from the ice pack. Alright? Okay, so we can say for this example, heat energy is transferring from I'll just say transferring in terms of the system, right, into the system, right? Because the ice pack, the system, is receiving heat from the kid. Okay, so that deals with the energy. right? What about matter? Does matter transfer into or out of the ice pack? Well, if you think about the ice pack again, okay, this is an ice pack. Some students might think, okay, Mr. Ta, there's going to be water on the outside of the ice pack. And water is made of matter, right? Matter is anything that has mass and takes up space. And, you know, the water appears outside. Right? But we have to question where that water came from. And some students might think, okay, the water came from the ice pack, right? And once it melts, it becomes liquidy, and then the liquid comes, like, goes through the bag and comes to the outside of the ice pack. I have a few examples where you can counter that. If you get a block of some metal and you put it in the freezer, okay, you get a block of metal and you put it in the freezer. After you wait until it's really cold, and you bring that block of metal out and put it into the kitchen counter, so that it's at room temperature, that block of metal will also get water. But we do know that water is not inside, you know, a solid chunk of metal. So where did that water come from? You might already know this, but there's actually water vapor in the air. There's water vapor in the air, right? In the air that's around us right now, that just means that there's gaseous form of water in there. Okay, and sometimes if there's a lot of water vapor, we say it's very humid, right? Well, that water vapor, if it touches the ice pack and the ice pack is cold, then you have these particles of water vapor touching something that's cold, right? And if it touches something that's cold, it transfers energy into the ice pack. And then when it loses that energy, it becomes slower. It gets less kinetic energy, it becomes slower, and what that means is its temperature drops. So this water vapor that's touching the ice pack will get colder, it will drop in temperature, and then water vapor becomes liquid. Alright. When that water vapor is starting from the outside, and then it condenses or it becomes a liquid and it's still on the outside, that means it never came from the inside. Okay? And that means that it couldn't have lost matter. It couldn't have matter couldn't have gone from the inside of the ice pack to the outside of the ice pack. And then the same thing can be said for from the outside of the ice pack, matter couldn't have gone into the ice pack, because ice packs generally they're reusable. And they are reusable indefinitely, like infinite times, right? You just throw it back in the freezer, and then you take it out, and you basically have another, you know, new ice pack. And since it is reusable, it's implying that matter didn't go in and matter didn't come out of it, right? Because if matter does go into it and matter comes out of it, you would either get like a deflated ice pack with nothing inside, or you'd get an inflated ice pack where there's a lot of stuff inside. But we know that's not true. It stays basically the same size. When you put it in and when you take it out of a freezer, it stays basically the same size. So no, matter is not transferred from the ice pack to the surrounding, from the system to the surrounding, and matter is not transferred from the surrounding into the system either. Okay. So that's only if we define the system to be the ice pack. What if we define the system to be something else? Right? So here's the second example. What if we said that the system is now the illest child of 2020? So now the kid is the system. Okay, so I'm gonna undo my drawing right here surrounding the, oops, that's a highlight. I'm gonna erase this. Now let's say that the kid himself, assuming this kid is a boy, the kid, I'm trying to outline the kid. The kid is the system. What if the kid is the system? Then that means the surrounding is everything else other than the kid. And we can ask ourselves the same question. What is transferring in and out of the system? Or, in other words, what is transferring in and out of the kid? Is there any energy or matter transferred? That's what it's asking. Is there any energy or matter transferred in and out of this kid, in and out of this system? Well, let's think about energy again. Okay, energy. Well, the kid is experiencing the coldness from the ice pack, right? That must mean that the kid is losing heat to the ice pack. So yes, there's definitely energy leaving the system. Heat energy, again, is transferred out of the kid. So it's going out of the system. Okay, what about matter? Okay, is there any matter going in and out of the kid? Well, this kid is still breathing, right? Assuming this kid is still alive. Breathing. There's gas being exchanged from the system, the kid, and the kid's surrounding, right? When you breathe in, you probably know that you're breathing in oxygen gas. And then when you breathe out, you're exhaling, you probably know this, carbon dioxide, right? And these gases, they take up room. You can inflate a balloon and see that they take up volume. And these gases, if you put like an empty balloon on a scale, and then you fill it up with either oxygen gas or carbon dioxide, and then you put it on a scale again, it would actually have an increased mass. So oxygen gas and carbon dioxide, which is exchanged from the system with the surrounding, that is matter. So I can say CO2 is transferring out, O2 is transferring in. Right? So matter is being exchanged with surrounding. Some students have previously said sweat. Yeah, sweat from the kid is transferring out, right? It's going from the kid to the environment. Because this kid is, it's 100.4 degrees Fahrenheit. This kid must be sweating too. So he's losing a little bit of mass to the environment through sweat. Okay, so that's if the system was the kid. Okay, we have one last example. What if the system was not the kid, not the ice pack, but the thermometer? What if the system was the thermometer instead? Well, the surrounding would be everything else other than a thermometer. And then we have the same question. What is transferring in and out of the system? Is there any energy and matter that's transferred in and out of the thermometer? Okay, so thermometer, looks like this, right? It's usually enclosed in glass, and inside we have liquid alcohol, actually. It used to be liquid mercury, but then we found out, oh, mercury is dangerous, so we swapped it to alcohol, which is not as dangerous. Is there any energy transferring into the thermometer or out of the thermometer? Well, the thermometer, if you look at the picture, is stuck into the kid. And a thermometer isn't usually 100 degrees Celsius to start off. It's usually room temperature. Alright, but if you stick this thermometer into a hotter environment, such as a kid's mouth, what happens to the alcohol inside the thermometer is it absorbs that heat from the kid. And when it absorbs that heat, it actually causes the particles, the alcohol particles in the liquid, to move faster, right? When it absorbs energy, it increases an average kinetic energy, and it moves faster, and that means there's a higher temperature, right? And if it's literally moving faster, those alcohol molecules are bumping into each other in the bulb. It's bumping into each other so much that it starts to bump the rest of the alcohol molecules up, and it causes that thermometer to go up in temperature. And that's literally what happens when the alcohol absorbs thermal energy. That's going to increase the temperature of the alcohol, and increased temperature means there's more average kinetic energy of those particles, and it causes them to bump into each other and push that liquid up the narrow neck of a thermometer. And that's how an alcohol thermometer operates. Okay, so yes, it does cause energy, or the system does get energy transferred into it if the system is a thermometer. So heat energy is transferring into the system. Okay, so definitely energy does transfer in. Is there any mass, or matter rather, that transfers in or out of a thermometer? But for this one, just think about the thermometer again. A thermometer is basically enclosed. This type is enclosed in glass. That means no air, no liquid, or no solid can get into the thermometer. And you kind of could understand this because a thermometer is also reusable, like indefinitely, right? That's because nothing is going in or out of the thermometer in terms of matter. Okay, so for this one, only energy can transfer into the thermometer. Energy can also transfer out if you're saying that the thermometer is laying in room temperature. It can cool down, so it can release that heat energy back out. Okay, so based on how you define the system, you can think about how energy moves in or moves out, and how matter moves in or moves out. This is important when we're thinking about the different types of systems. So this is going to be the next page. Okay.